Welcome everyone. Today we are exploring a fundamental topic for building generative AI applications using Microsoft Foundry, deploying and securely consuming various types of foundation models. Welcome everyone. Today we are exploring a fundamental topic for building generative AI applications using Microsoft Foundry, deploying and securely consuming various types of foundation models. When you begin your architectural journey in Microsoft Foundry, you are immediately introduced to the model catalog. This catalog is an extensive, centralized hub featuring over 1,900 foundation models from Microsoft, OpenAI, Black Forest Labs, and other leading industry providers. These available models range from massive large language models designed for incredibly complex reasoning, to highly efficient small language models like the Phi family, and even highly specialized code and multimodal models. But with so many options, how do you choose the right one? Selection must be driven entirely by objective data. The Foundry catalog provides comprehensive benchmark metrics to actively guide your decision. You must evaluate models based on critical generation quality metrics like groundedness, coherence, and fluency. Additionally, you must consider throughput, which strictly measures how quickly the specific model processes prompts, and the overall token cost efficiency. For instance, if you are building a simple text classification tool, using a massive, expensive LLM is architectural overkill. A smaller model will achieve the exact same result, with significantly lower latency and cost. By rigorously filtering the catalog by specific inference task, such as text-to-image, document translation, or conversational chat, and meticulously comparing these precise benchmarks, you completely ensure your enterprise applications are built on the absolute most optimal cognitive engine available to you. Let us now move forward and look at exactly how we deploy these selected models into our Azure environment. Programmatically fetching benchmark metrics allows enterprise architects to actively evaluate cost and throughput efficiencies before committing to a costly production deployment. This flowchart shows the selection process. Starting from the massive model catalog, you filter by inference task, evaluate strict benchmarks for quality and cost, and ultimately select the optimal model. Once you have successfully selected the perfect model from the catalog, the next critical step is deployment. In Microsoft Foundry, deploying a model transforms it from a static, hosted asset into a scalable, live API endpoint that your client applications can securely consume. When you click Deploy in the Foundry portal, you must make a crucial architectural decision, choosing the correct deployment type. Microsoft Foundry supports several distinct deployment tiers, each offering different characteristics for scaling, data residency, and billing. As highlighted in the official documentation, for mission-critical, customer-facing applications that demand maximum quota and high throughput, you should absolutely select the global standard deployment tier. If your engineering team is simply prototyping internally or needs a low-cost environment for initial testing, the developer tier is the ideal choice. Finally, for massive, asynchronous data processing where real-time latency is entirely irrelevant, such as nightly document summarization jobs across thousands of files, you can uniquely utilize data zone batch deployments. Properly matching your anticipated user traffic and latency requirements to the correct deployment type is absolutely essential for strictly managing your cloud expenditure and actively preventing aggressive rate-limiting errors. Once successfully deployed, the model is physically accessible via specific Azure URIs, and you are completely ready to authenticate and route your application's prompts directly to this highly intelligent backend infrastructure. By mastering these specific deployment models, you definitively guarantee a seamless, highly responsive user experience, while expertly optimizing your overall cloud operational costs. This Python snippet demonstrates how to deploy a model programmatically using the SDK, specifically selecting the global standard tier to ensure maximum quota for high-volume production traffic. This decision tree illustrates the deployment options. Based on your specific workload, you route the deployment to global standard, developer, or batch tiers to provision a live API endpoint. With your model deployed and running actively as a live endpoint, how does your client application actually communicate with it? Microsoft Foundry provides immense architectural flexibility here, offering two primary endpoint types and two corresponding software development kits, or SDKs. First, it is vital to understand that every single Foundry project exposes two distinct endpoints, a project endpoint and an Azure OpenAI endpoint. To effectively consume these endpoints, you can choose to use the Microsoft Foundry SDK, which is easily installed via the Azure AI Projects package in Python. This specific SDK gives you comprehensive, native access to advanced project-level features like autonomous agents, programmatic evaluations, trace logging, and secure Foundry IQ data connections. Alternatively, if you are migrating existing code, you can use the standard OpenAI SDK, which provides full OpenAI API compatibility strictly for core model inference operations. Regardless of the specific SDK you choose to implement, security must absolutely be your top priority. You should aggressively avoid using hard-coded plain text API keys in your applications. Instead, production applications should strictly use Microsoft Entra ID authentication. By leveraging the default Azure credential class, your code seamlessly negotiates with Entra ID to obtain a short-lived, highly secure OAuth token. This ensures that your client application is running exactly in the context of a specific, managed identity, completely eliminating the severe risk of credential leakage. Implementing this modern identity-based security model is the foundational step in protecting your deployed LLMs. Let us look at the specific APIs used for these generative interactions. This configuration securely initializes the Microsoft Foundry SDK client using default Azure credential, seamlessly authenticating via Microsoft Entra ID without exposing any vulnerable API keys in the source code. This diagram maps the connection pathways. Client applications securely authenticate via Entra ID and use either the Foundry SDK to access full project features or the OpenAI SDK for direct model inference. When actively developing a generative AI chat application, your client code will primarily interact with the deployed language model using one of two core APIs, the legacy chat completions API or the newer responses API. While the chat completions API remains a well-established standard that is highly compatible across many generative AI platforms, the responses API is strongly recommended for almost all new development projects within Microsoft Foundry. This is explicitly because of its advanced conversational state management and its incredibly deep native integration with Foundry agent features. When you prompt a standard text or code model, you securely send an array of messages, heavily relying on system instructions and user queries. However, we can push these language models much further by intelligently integrating tools. For example, if you deploy a model that is highly optimized for coding tasks, you can seamlessly bind the code_interpreter tool directly into your API request payload. The Code Interpreter tool natively enables the model to dynamically generate, physically execute, and accurately evaluate Python code within a highly secure sandbox environment to perform complex calculations, data analysis, and iterative problem-solving right on the fly. Furthermore, you can extensively use the function tool, which securely allows the model to output structured JSON, instructing your backend application to run custom business logic like checking a secure inventory database, and return the live result back to the model context. By mastering the responses API and deeply integrating these powerful tools, you completely elevate your language models from simple text generators into highly capable, autonomous orchestrators. This Python snippet demonstrates how to submit a prompt using the inference client, while actively attaching the code_interpreter tool, explicitly granting the model the powerful ability to execute Python code to calculate the requested variance. This flow explicitly illustrates tool execution. The application calls the model, which securely invokes the code interpreter, runs logic in an isolated sandbox, and uses that computational result to formulate the final response. Modern generative artificial intelligence extends far beyond simple text generation. Microsoft Foundry provides extensive, robust support for multimodal models, securely enabling your enterprise applications to process and generate rich media, such as images, audio, and high-definition video. If your application specifically needs to generate original graphics, you can easily deploy advanced models like the OpenAI GPT Image 1 series, or the highly creative Black Forest Labs Flux models directly from the catalog. Using the standard image API, you submit a highly descriptive text prompt and instantly receive high-quality, photorealistic images or stylized illustrations. If you need to forcefully generate video content, you can deeply integrate the Sora 2 model. Because video generation is a massively resource-intensive, asynchronous process, your Python application must submit a dedicated generation job specifying parameters like resolution and duration, continuously pull the API for a completed status, and then securely download the final MP4 file before the 24-hour expiration window. Conversely, you can use highly advanced vision-capable models such as 5.4 Multimodal Instruct, GPT 4.1, or GPT 4.1 Mini to accurately analyze complex visual inputs. With these vision models, you can easily upload an image from a local file alongside a text prompt, for example, explicitly asking the model to interpret a complex financial data chart or accurately assess a photograph for physical product damage. By aggressively leveraging these diverse multimodal models, you can build incredibly interactive, vision-enabled chat applications that see and fully understand the real world just as effectively as they read text. This code explicitly highlights the asynchronous nature of consuming massive video models like Sora 2. The client submits the prompt parameters, creating a cloud job that must be actively polled until the video is fully rendered. This multimodal architecture maps specific requirements to the correct models: text-to-image models for graphics, asynchronous Sora 2 jobs for video generation, and powerful vision models for active image analysis. Finally, we must critically examine speech capabilities and how to efficiently transition your work from rapid prototyping directly into production code. Microsoft Foundry offers specialized, highly optimized audio models like GPT-4 OTTS and GPT-4 O-mini TTS that can flawlessly synthesize natural-sounding speech directly from text or perfectly transcribe spoken audio streams into readable text payloads. Furthermore, you can actively utilize Azure Speech within Foundry tools to implement these exact capabilities, seamlessly enabling your engineering teams to build fully hands-free AI assistants and highly accessible, voice-driven conversational interfaces for your users. Crucially, before you ever write the final integration code for any of these complex text, vision, or speech models, you should absolutely always rigorously test them in the Microsoft Foundry Model Playground. The Playground acts as an interactive, safe, no-code environment where you can dynamically adjust execution hyperparameters like temperature, strictly test different system messages, and manually upload reference images to observe the model's exact behavior. Once you successfully achieve the desired output quality, the Playground provides an absolutely massive productivity boost, the View Code tab. Here, Foundry automatically generates the exact Python, C# or JavaScript SDK boilerplate code heavily required to replicate your exact Playground settings programmatically. You simply copy this code directly into your source repository. Thank you for joining me for this comprehensive deep dive into deploying and consuming Microsoft Foundry models. If you found this technical training valuable, please actively like and subscribe to the channel. For premium certification prep, including massive Q&A banks, comprehensive ebooks, expert audiobooks, and exclusive interview guides, absolutely visit quicktechie.com. See you in the next module. This specific snippet represents the boilerplate code exported directly from the Playground, demonstrating how effortlessly you can invoke the text-to-speech API to reliably synthesize spoken audio using a highly specific voice profile. This workflow shows the active prototyping lifecycle. You use the Model Playground to strictly test prompts and parameters, thoroughly validate the output quality, and directly export the exact SDK code needed for your production application.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.